Hi, good day. Today I have come with an important topic, which is human groundwater extraction, shifting Earth's axis and environmental implications. Let's start. In an increasingly interconnected world, human activities have far-reaching consequences on the Earth's delicate balance. While we often acknowledge the impact of climate change and deforestation, a lesser-known but significant phenomenon has recently come to light: the shifting of Earth's axis due to extensive groundwater extraction. As highlighted in a groundbreaking study, published by researchers from the University of California, humans have pumped an astounding amount of groundwater, resulting in an observable shift in Earth's rotation. This article explores the implications of this discovery, the mechanisms involved, and the urgent need for sustainable groundwater management. The mechanism behind the shift. Groundwater, the water stored beneath the Earth's surface and underground aquifers, has been a vital resource for human civilization for centuries. Over the past few decades, however, our demand for groundwater has escalated dramatically, driven by population growth, agricultural needs, and industrial activities. The extraction of vast amounts of groundwater has caused the subsidence of land in many regions, leading to significant geological changes. The direct consequence of extensive groundwater extraction is the redistribution of mass on Earth's surface. As water is pumped out, it is no longer evenly distributed across the planet. This redistribution of mass alters the planet's rotational inertia, similar to an ice skater changing her spin when her arms are extended or contracted. Consequently, Earth's rotation slows down slightly, resulting in a shift in its axis. The study and observations. The research conducted by the University of California scientists, as published in the journal Science Advances, sheds light on the magnitude of this phenomenon. By analyzing data from satellite observations and GPS measurements, they found that from 1981 to 2013, humans have extracted around 1,000 cubic kilometers, 240 cubic miles, of groundwater globally. This immense volume of water removal has caused a shift in the Earth's axis by approximately 2.5 centimeters, 1 inch. While this shift may appear minuscule, it is a tangible manifestation of our unsustainable groundwater practices. It serves as a wake-up call, underlining the potential consequences of unregulated extraction and its impact on the Earth's intricate dynamics. Environmental implications. The implications of the shifting axis extend beyond a mere scientific curiosity. The repercussions are multifaceted and affect various aspects of our environment, including climate patterns, sea level rise, and geophysical stability. Climate patterns. The redistribution of mass due to groundwater extraction can influence climate patterns, such as regional rainfall distribution. Alterations in groundwater availability impact the overall water cycle, potentially leading to droughts in some regions and increased rainfall in others. These changes can disrupt ecosystems, agricultural productivity, and the livelihoods of communities dependent on predictable weather patterns. Sea level rise. Groundwater extraction contributes to sea level rise through two primary mechanisms. Firstly, as groundwater is pumped out, it eventually finds its way into the oceans. Secondly, land subsidence caused by excessive extraction can result in coastal regions sinking further, exacerbating the effects of rising sea levels. Both of these factors contribute to the loss of coastal land, increased vulnerability to storm surges, and saltwater intrusion into freshwater sources. Geophysical stability. Land subsidence caused by groundwater extraction can lead to the destabilization of the Earth's crust. This increases the risk of ground fissures, sinkholes, and land deformation. In areas prone to seismic activity, such as earthquake-prone regions, the withdrawal of large amounts of groundwater can even trigger or intensify earthquakes. The way forward: sustainable groundwater management. To mitigate the adverse effects of groundwater extraction and halt the shifting of Earth's axis, urgent action is necessary. Sustainable groundwater management strategies are pivotal in achieving this objective. The following measures can help address the issue. Regulation and monitoring. Governments must enforce regulations to limit excessive groundwater extraction. Monitoring and metering systems should be implemented to ensure compliance and track usage accurately. Water conservation. Promoting water conservation practices, such as efficient irrigation techniques, rainwater harvesting, and recycling, can reduce reliance on groundwater. Alternative water sources. Diversifying water sources through investment in surface water reservoirs, desalination plants, and wastewater treatment facilities can alleviate the pressure on groundwater resources. Public awareness and education. Raising awareness about the importance of sustainable groundwater management and its link to environmental stability is essential. Education programs can empower. The discovery that extensive groundwater extraction has shifted Earth's axis serves as a stark reminder of our collective responsibility to manage Earth's resources sustainably. The implications of this phenomenon extend beyond a mere scientific curiosity, encompassing climate patterns, sea level rise, and geophysical stability. Urgent action, including regulation, conservation, diversification, and public awareness, is imperative to ensure the sustainable management of groundwater resources and protect our planet's delicate equilibrium for future generations. I hope you liked the article. Here is some glossary for you to know the meanings of difficult words. Deforestation. The action of clearing a wide area of trees. A key aim is to try to halt widespread deforestation in the Amazon. Astounding. Surprisingly impressive or notable. The summit offers astounding views. Implication. The action or state of being involved in something. Our implication in the problems. Sustainable. Able to be maintained at a certain rate or level. Sustainable economic growth. Aquifers. An aquifer is a body of rock and/or sediment that holds groundwater. Groundwater is the word used to describe precipitation that has infiltrated the soil beyond the surface and collected in empty spaces underground. Planet's rotational inertia. The moment of inertia controls the rate at which a planet spins, and the location of the spin axis depend on the distribution of mass in each body. We illustrate this concept by racing a metal ring and disk, which have the same mass but different moments of inertia, down an incline. Minuscule. Extremely small, tiny. A minuscule fragment of DNA. Manifestation. The action or fact of showing something. The manifestation of anxiety over disease. Intricate. Very complicated or detailed. An intricate network of canals. Curiosity. An eager desire to learn, and often to learn what does not concern one. Inquisitiveness. Something strange or unusual. The curiosities of nature. Repercussion. An unintended consequence of an event or action, especially an unwelcome one. The move would have grave repercussions for the entire region. Drought. Drought is a prolonged dry period in the natural climate cycle that can occur anywhere in the world. It is a slow-onset disaster characterized by the lack of precipitation, resulting in a water shortage. Drought can have a serious impact on health, agriculture, economies, energy, and the environment. Disrupt. Interrupt an event, activity, or process by causing a disturbance or problem. Flooding disrupted rail services. Ecosystems. An ecosystem is a geographic area where plants, animals, and other organisms, as well as weather and landscape, work together to form a bubble of life. Ecosystems contain biotic or living parts, as well as abiotic factors, or non-living parts. Biotic factors include plants, animals, and other organisms. Exacerbating. Make a problem, bad situation, or negative feeling worse. The exorbitant cost of land in urban areas only exacerbated the problem. Vulnerability. The quality or state of being exposed to the possibility of being attacked or harmed, either physically or emotionally. Conservation authorities have realized the vulnerability of the local population. Storm surge. Storm surge is an abnormal rise in sea level over and above the normal, astronomical, tide levels. It can be thought of as the change in the water level due to the presence of a storm. These powerful ocean movements are caused by strong winds piling water up against the coast as a cyclone approaches. Saltwater intrusion. As sea levels rise along the coasts, saltwater can move onto the land. Known as saltwater intrusion, this occurs when storm surges or high tides overtop areas low in elevation. It also occurs when saltwater infiltrates freshwater aquifers and raises the groundwater table below the soil surface. Land subsidence. Land subsidence is a gradual settling or sudden sinking of the Earth's surface due to removal or displacement of subsurface Earth materials. The principal causes include aquifer system compaction associated with groundwater withdrawals, drainage of organic soils, Earth's crust. Earth's crust is generally divided into older, thicker continental crust and younger, denser oceanic crust. The dynamic geology of Earth's crust is informed by plate tectonics. Crust describes the outermost shell of a terrestrial planet. Ground fissures. A ground fissure, also called an earth fissure, is a long, narrow crack or linear opening in the Earth's crust. Sinkholes. A sinkhole is a depression in the ground that has no natural external surface drainage. Basically, this means that when it rains, all of the water stays inside the sinkhole and typically drains into the subsurface. Seismic activity. Seismic activity, from the Greek seismos, earthquake, is the frequency and severity of earthquakes in a given region. Seismology is the study of earthquakes. Earthquake-prone. A building, or part of a building, is earthquake-prone if it is likely to collapse and cause injury or death, or damage to another property, in a moderate earthquake. Pivot. Extremely important. Water conservation. Water conservation is the practice of using water efficiently to reduce unnecessary water usage. According to Fresh Water Watch, water conservation is important because fresh clean water is a limited resource, as well as a costly one. Rainwater harvesting. Rainwater harvesting is collecting the runoff from a structure or other impervious surface in order to store it for later use. Traditionally, this involves harvesting the rain from a roof. The rain will collect in gutters that channel the water into downspouts and then into some sort of storage vessel. Diversify. Sad face of a business. Enlarge or vary its range of products or field of operation. The company expanded rapidly and diversified into computers. Desalination plant. Desalination plant removes dissolved salts from seawater, using a reverse osmosis process. This produces high-quality drinking water that meets our strict quality requirements, like all our water, including standards set by the Australian Drinking Water Guidelines. Stark reminder. Something that serves as a reminder of another thing makes you think about the other thing. Encompass. To form a circle about. Surround. To cover or surround, especially so as to hide or protect. To take in as a part. Include. Encompassment. Geophysical. What is an example of geophysical? Specifically, some of the areas geophysical engineering deals with are 1. Exploration of coal, oil, gas and geothermal energy resources as well as groundwater and mineral deposits. 2. Assessment of earthquake hazards such as strong ground shaking, landslides and liquefaction. Thanks for watching. Please subscribe, share and comment. Stay connected.